All right, so we're in section 4.6 now. So let's start off. Let's start off by talking about the tangent function a little bit. So we know that tangent theta, one of our identities, is sine theta over cosine theta. So thinking about this function and how sines and cosines behave, and also thinking back to chapter 2 when we talked about rational functions, what is going to happen with the graph of the tangent function? What do we have to be careful with when we have functions where we're dividing a function by a function? It can't be zero. So what's going to happen? What's going to happen to this function when the cosine of theta equals 0? What's that? Okay, so our function is going to be undefined. And what happens to the graph of a function when we have an undefined function? We get asymptotes. So this is going to have an asymptote everywhere the cosine theta is 0. So since we have an asymptote everywhere cosine theta equals 0, cosine theta equals 0 at pi over 2, 3 pi over 2, etc., etc. So we're going to have asymptotes at these multiples of pi over 2. So the way we write that is where theta equals pi over 2 plus n pi, where n is just some integer. So we're at pi over 2, we can add pi to that and get to 3 pi over 2, add another pi and get back up to a coterminal angle with pi over 2, and we just keep going that way. So we're going to get asymptotes, we're going to get a bunch of asymptotes with our graph. And because we get an asymptote every pi over 2 units, there's pi units between those asymptotes, the period of our tangent function is going to be pi rather than 2 pi, because we get an asymptote every pi units. Between pi over 2 and 3 pi over 2 is pi units. So we get a period of pi, and our tangent function is odd. So let me grab a picture so we can take a look. That's not what I want to do. I want to go here to get my picture. So there's a picture of the graph of the tangent function. So we have an asymptote. The way I've sketched the asymptotes here at negative pi over 2 and pi over 2. But we have another one here at 3 pi over 2. And they just keep repeating. If we look back here at this graph, this just keeps going and keeps going and keeps going and keeps going. So we have an asymptote at these multiples of pi over 2 plus pi units. So our function is odd. The other important thing about the tangent function is it is increasing. So it's going up, it's getting larger as we move left to right. So our period is pi. We get asymptotes at these multiples of pi over 2 plus pi units. And odd means it's symmetric about the origin, just as a reminder. So we're going to use this information. We're going to use this information to graph tangent functions that various things have been done to. So let's take a look at how we're going to do that. We're going to look at y equals, and we're going to write all of our stuff that we can do to our function all together. D plus a tangent bx minus c. So what does d give us? What does d do to this function? Vertical shift. A, we call A the amplitude for sine and cosine. It doesn't really make sense for the tangent function because it's not going up and then back down. So just in terms of how it changes a function, what does A do to this function? Stretch. It's going to give us a vertical stretch. And we'll talk about how we deal with that in just a second. Our period. Since the period of tangent is pi, our period is going to be changed to pi over b. So with sines and cosines, it was 2 pi over b. For tangent, it's going to be pi over b. And then our horizontal shift is we need to factor out this b just like we did when we graph sines and cosines. Our horizontal shift is going to be c over b when I factor that b out. So those are all the things we can do to this function. Our intercepts. We're going to find an x-intercept. Halfway between the asymptotes. And we're going to use our stretch. We're going to say that y equals plus or minus a halfway between the intercepts and the asymptote. We've got some letters here. So y is going to be plus or minus a halfway between the intercepts and asymptotes. So let's look at why that would be. Just going to go back here to our graph. So we have an intercept here at x equals 0 and an asymptote at pi over 2. Halfway between 0 and pi over 2 is what? Pi over 4. The tangent of pi over 4 is one. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. So the tangent of pi over 4 is 1. So when I stretch and when I change the period, the point that's halfway between the intercept and asymptote will always have me taking the tangent, finding the tangent of pi over 4. Tangent of pi over 4 is 1. And then I just have 1 times a. Now if we shift up, if we have a vertical shift, then our stretch is going to be above and below where we've shifted our vertical shift to, just like we did for our maximum, our amplitude for sines and cosines. So if we shift, this is going to be above and below our vertical shift. So let's look at a couple of examples of using this information to graph a tangent function. So we have y equals, what do we have? 2 tangent 2x. So I'm going to write down a little information here. A equals 2, so we know we have a vertical stretch of 2. And our period, b equals 2, so our period is pi over 2. We don't have any shifts up or down. We don't have any shifts left or right. Yes? Our period of tangent is normally pi. And then to find the period of this stretched or compressed function is going to be pi over b, just like we did with sines and cosines. So I'm going to find, the way I'm going to find an asymptote normally a tangent function has an asymptote at multiples of pi over 2. So I'm going to say we're going to have an asymptote where 2x equals minus pi over 2. So on the first graph we looked at, we had an asymptote at pi over 2. So I'm going to find where this, whatever this thing is we're finding the tangent of, where that equals negative pi over 2. So that tells me I'm going to have one at negative pi over 4. And where 2x equals positive pi over 2. So I can find my successive asymptotes by setting this equal to negative pi over 2 and pi over 2. So x equals pi over 4. Tangent function is always going to have those asymptotes where this thing is multiples of pi over 2. All right, so I can start sketching my graph. Probably have to find a little bit more information after we start sketching. So I'm going to put my first asymptote at negative pi over 4. And the next asymptote at pi over 4. And we can check to make sure we've done this correctly. The period is pi over 2. From negative pi over 4 to pi over 4 is pi over 2 units. Our intercept is going to be right in between at x equals 0. And this is going to be positive 2 and negative 2. And then halfway between the intercept and the asymptote, this will be at pi over 8 and negative pi over 8. Halfway between 0 and pi over 4. My y is going to be plus and minus 2. We know the tangent function is increasing, so it's going to be positive 2 there, and it's going to be negative 2 there. So there's a graph of one period of that function. To graph another period, I'm just going to go out. I'm going to add one period to where this asymptote is, at pi over 4, and sketch another asymptote. So what's pi over 4 plus pi over 2? I want to go out pi over 2 units past this asymptote to find another asymptote. 3 pi over 4. Pi over 4, 1/4 plus 1/2 is 3/4. So I'm going to have another asymptote at 3 pi over 4. Halfway between pi over 4 and 3 pi over 4 is 2 pi over 4, which is pi over 2. There we go. Lots of fractions here. I said hopefully we would love to learn to love fractions. So halfway between pi over 4 and 3 pi over 4 is pi over 2. So we're going to have an intercept there. And then right in the middle of that interval, we're going to go up to positive 2 and down to negative 2 here. And there would be the second period of that tangent function. And if we wanted to sketch more periods, we would just extend each of our important points by pi over 2 units, which is our period. So I could go out another pi over 2 with each of these. And we said our period was pi over 2. We can check our work. Our period's pi over 2. Well, from 0 to our next intercept should be 1 period, and that is pi over 2 units. From asymptote to asymptote, pi over 2 units. So we've sketched our graph. That's a way to check to see if we've sketched our graph correctly. All right, questions on how we construct that graph? We know that an untransformed tangent function has an asymptote at negative pi over 2 and positive pi over 2. So we go back to, let me go back to this graph. We have an asymptote here at negative pi over 2 and pi over 2. So I say that this one is going to have an asymptote where 2x, where whatever we're taking the tangent of, 2x equals negative pi over 2 and 2x equals positive pi over 2. It's going to give us an asymptote. All right, let's look at a tangent function where we're doing a little more to it. Y equals two tangents 2x minus pi over 2. So we have some stretches and we have some shifting going on here. So I'm going to rewrite that right away as tangent 2 times x minus. When I factor that 2 out of this pi over 2, what am I left with? Pi over 4. So I know that a equals 2. Our period is pi over 2, pi over b. And this pi over 4 is going to do what to my function? Shift right by pi over 4 units. So my period's pi over 2, I'm shifting right by pi over 4 units. I'm going to find my asymptotes, 2 successive asymptotes. Where 2x minus pi over 2 equals negative pi over 2. We know our tangent function is going to have an asymptote at negative pi over 2 if it's unshifted, so we're going to figure out where the shifted asymptote is. I add pi over 2 to both sides, I get 2x equals 0 or x equals 0. So I'm going to have one asymptote at x equals 0, and where 2x minus pi over 2 equals positive pi over 2. This tells me that 2x equals pi over 2 plus pi over 2 is pi, or x equals pi over 2. So I get an asymptote at x equals 0, asymptote at x equals pi over 2. My period is pi over 2. The distance between my two asymptotes is pi over 2. So that tells me I've done that step correctly. All right, so let's start sketching. Here's my asymptote at x equals 0. Here's my asymptote at x equals pi over 2. And if I want to sketch, I want to put the asymptote for the next period in right away. My period is pi over 2, so where's my next asymptote going to go? if this one is at pi over 2? Pi. Pi over 2 plus my period of pi over 2 is just pi. Halfway between the asymptotes is where I get my intercepts. Halfway between 0 and pi over 2 is pi over 4. Halfway between pi over 2 and pi. What is it? Three pi over 4. Halfway between 1/2 and 1 is 3/4. And we know that halfway between our intercepts and our asymptotes, y equals plus or minus a. So if this is pi over 4, this is going to be pi over 8. And halfway between pi over 4 and pi over 2. What is it? How do we figure out what's halfway between pi over 4 and pi over 2? Add and divide by 2. So pi over 4 plus pi over 2 divided by 2, what is it? 3 pi, so this is 4 pi, or 2 pi over 4, 3 pi over 8. So that point is 3 pi over 8. So now we can start sketching our graph. So here is, we know that our tangent is increasing, so we're going to be at -2 here and +2 here. And my function kind of missed my intercept. I'll make my intercept bigger. There we go. And same thing in the middle between these two. And there's a graph of one period of that transformed tangent function. And the distance between successive asymptotes is our period, pi over 2. The distance between successive intercepts is pi over 2. So we've done everything correctly. We've shifted right by pi over 4. So our graph checks with what the information tells us. So questions on that one? So lots of dividing things by 2 when we're dealing with tangent functions, finding the middles of things. All right, let's talk about cotangents. Well, cotangent, we know, is cosine theta over sine theta. So we still have this function that's made up of a fraction. So we're going to get asymptotes. Where are asymptotes going to show up this time? What's going to give us an asymptote for this one? When sine theta equals 0, when our denominator equals 0. And we know that sine theta equals 0 at 0, pi, 2 pi, etc. So these multiples of pi. So the way we write that is theta equals n pi, where n is some integer. So we get a 0 pi, 1 pi, 2 pi, 3 pi, any multiple of pi, we get an asymptote for the cotangent. All right, let's look at, let me grab a graph of the cotangent function. There we go. And this, it says 1 over tangent x because Sketchpad doesn't have a cotangent function. So we have to do the reciprocal of the tangent. So there is my asymptote at 0. There's an asymptote at pi. We have another asymptote here at 2 pi, at negative pi, etc. So a couple other important things about this function. It is also odd. And it is decreasing. So as we move from left to right, it's going downhill. A lot of times students get confused. If we flip the tangent function over the x-axis, it kind of looks like this. But the tangent function unshifted goes through 0. The cotangent function has an asymptote at 0. So they're shifted from each other by pi over 2 units. All right, so let's take a look at how we're going to use this information. I forgot one piece here. Because we have an asymptote at multiples of pi, our period is going to be pi, just like for tangent. So our tangent and cotangent, our period is pi. So let's talk about how we're going to use this information to sketch our graphs. So we have y equals d plus a cotangent bx minus c. Just like before, everything is the same. D gives us a vertical shift. A gives us a vertical stretch. Our period is pi over b, and our horizontal shift is c over b. Good. So the main difference here is where our asymptotes are going to be found. So we're going to find our asymptotes where bx minus c, I'm going to set that equal to 0 to find one asymptote, and bx minus c equals pi. For our tangent function, we set bx minus c equal to negative pi over 2 and positive pi over 2. Did we write that on our page? You might want to add that to this page. Asymptotes, if you have room where you wrote this. So we find two successive asymptotes where bx minus c equals minus pi over 2 and bx minus c equals positive pi over 2. So we're just finding our shifted asymptotes. And for cotangent, it is where bx minus c equals 0 and pi. So we're shifting over by pi over 2 units. Our x-intercepts are still halfway between the asymptotes, and halfway between the intercept and the asymptote, y is still plus or minus a. But we know our function is decreasing. So all of those things are the same. So let's graph a cotangent function. Y equals 3 cotangent x plus pi over 2. So we know that a equals 3, b is 1, so our period is just pi. And this pi over 2 is going to do what to our function? Shift left by pi over 2. We're going to find our asymptotes. Where x plus pi over 2 equals 0. So this tells me x equals pi over 2. It's one asymptote. And where x, yes, thank you, negative pi over 2. And x plus pi over 2 equals pi.
How come I thought the correct equation was bx minus?
So here c is negative pi over 2. So bx minus negative pi over 2 is, that's where we get the plus. And that's why we said shift left. So that takes care of that. And then x plus pi over 2 equals pi. So x equals pi minus pi over 2 is pi over 2. All right, now we're ready to sketch our graph. So I'm going to put an asymptote here at negative pi over 2, and up here at positive pi over 2. And if I wanted to graph my asymptote for the next period over, I'm going to, my period is pi, so I go pi units from this asymptote. So pi over 2 plus pi is so where is this asymptote going to be? 3 pi over 2. So my intercept here is halfway between the asymptotes, so here at the origin, and then halfway between the intercept and the asymptote, we get plus or minus a, so this is going to be pi over 4 and negative pi over 4. And we know that the cotangent function is decreasing, so it's going to go downhill. So I'm going to go here, and I'm going to up to 3 here, and down to 3 there. And there is one graph of that cotangent function, one period. And then let's figure out the middle, what's halfway between pi over 2 and 3 pi over 2? Pi. And then halfway in between those two, I'm going to get a point up here at 3, and a point down here at negative 3. So there are 2 periods of that cotangent function graphed out. And we can check our work. We said the period was pi, so between 2 intercepts is pi units, so that checks out. Between our asymptotes is pi units, so that checks out. So it looks like we've done everything correctly. Now what does this graph look like? What if I flip this one over the x-axis? It looks like a tangent function, an unshifted tangent function. So this looks like y equals 3 tangent x. So an unshifted, or negative 3. It would be a negative because it's flipped. An unshifted tangent function that's flipped over. So a shifted, reflected cotangent function is the same as a tangent function. All right, questions on that one? So not quite as much going on with tangents and cotangent graphs. Finding the asymptotes is really the big thing. For cotangents, we're looking for where our, whatever we're plugging into our function is 0 and pi, and for tangent it's negative pi over 2 and positive pi over 2 to find successive asymptotes. Those are the two of the differences, and then we know that our cotangent is decreasing while tangent is increasing. Okay. Homework. There you go.